Welcome to Newscast 2024.
We have a series of new and fascinating physics news to show you. Arnav, do you want to start us off?
Sure, an interesting development in semiconductors. Today, Georgia Institute of Technology has worked hard to create a working semiconductor. This has created an opportunity for new computers with greater speed and efficiency to be made. That is, compared with silicon chips today. While previous research has shown that graphene can be made to act as a semiconductor on a smaller scale, it has never actually been scaled up to the size of a computer chip. However, Walter D. Hare and his colleagues have created graphene, which should be able to scale up as it relies on similar technologies to silicon. D. Hare compared the difference of speed and efficiency between silicon chips and graphene chips as driving on a gravel road versus driving on a motorway. Despite this discovery, some believe that this discovery does not mean the new world will switch from silicon to graphene, because it is a new research and still needs a lot of refinement for its quality and manufacturing. But it's still an interesting advancement in the world of semiconductors. Now, moving on to you, Rohan.
A new planet has been discovered. Astronomers have recently discovered a planet closer and younger than any other Earth-sized world identified up to this point. It's been called HD 63433d, and it's the third planet found in orbit around a star called HD 63433. It's so close to its star that it makes a full cycle around the star every 4.2 days. It's about 400 million years old and is about 73 light years away from our own sun, and is part of the constellation Ursa Major. It's the smallest confirmed exoplanet that is less than 500 million years old yet. One side of the planet is always facing the star, which means that that side can reach 2300 degrees Fahrenheit, which is equal to 1260 degrees Celsius. Due to this, it's not habitable for humans. However, it may be useful as it could be viewed and studied as an early Earth, which could lead to potential future discoveries within this field. And next we have Lucas telling us about the future of long-term space travel.
So, keeping in the theme of space and astronomy, so tell me guys, have you ever thought of living on a planet other than Earth?
Of course.
Yeah. Well, nowadays it's looking like more of a possibility than ever, because researchers have taken the first steps towards finding liquid solvents that may someday help extract building materials from lunar and Martian rocks, right? Which is important with making long-term space travel possible, right? So the Washington State University researchers have found about half a dozen good candidates for these solvents that can both extract materials and be usable in things such as 3D printing. It's important to us as it makes long-term missions possible, and astronauts will have to use these materials and resources in those extraterrestrial environments using 3D printing. That's the only way they're going to get it, right? So the extraction method also can't use water, right? Since it's not available on the moon. The powerful solvents, called ionic liquids, are salts that are in liquid state, but the researchers did not actually test these substances themselves. You would think that's kind of alarming, but there are big expenses here. So they used machine learning and modelling at the level of atoms, tiny, minuscule levels, right, to narrow down the potential candidates. They looked for solvents that digest materials, extract important elements such as aluminium, magnesium, iron, these essential elements. And also, what's really important is that they regenerate themselves and even produce oxygen and water, since these aren't readily available on the moon, so they have to be made as a byproduct of these to help support life as well. And so some of these have been found, and it makes the future of space travel and the possibility of us humans living somewhere else in the universe more of a possibility. It's looking more likely nowadays. So next up, Arnav, something to tell us.
Have researchers found a material harder than diamond? No. The second hardest substance has now been moved to third place, after Dominic Laniel and his colleagues have made a sample of carbon nitride. This was done by compressing both carbon and nitrogen between diamond points at 700,000 times atmospheric pressure, which is about 100 kilopascals, and heating it to 3,000 degrees with lasers. Diamond has a hardness of 90 gigapascals, and the new carbon nitride measures between 78 and 86 gigapascals, compared to the previous second place, which was 50 to 55 gigapascals. The samples are currently only 5 micrometers by 3 micrometers, and scaling up would be extremely difficult as stronger compressions and larger diamonds would be required. This would make the carbon nitride much more expensive than diamond to buy, but Laniel says this material has benefits that diamond doesn't, such as generating an electrical signal under pressure, making it useful in sensors. Its high energy density also makes it a very powerful explosive that is less toxic for the environment than current explosives. Now, moving on to you, Rohan.
So, obviously, as you both know, a big development that we want to kind of research more is quantum computers. But the thing is, these can't maintain themselves very well. However, a new development has been made at a university in Germany about quantum engines that could power devices with an ultra-cold atom cloud. So, a team led by Arthur Widera have developed a quantum engine powered by the constant shifting in the fundamental quantum nature of particles. The engine, constructed from a few 100,000 lithium atoms cooled to near absolute zero, utilizes carefully tuned magnetic fields to make the atoms behave alternatively as fermions and bosons. By compressing and expanding the atoms and switching between fermion and boson states, the researchers demonstrated the feasibility of driving an engine with a purely quantum form of energy for the first time ever. Although the current efficiency is only around 25%, there is potential for improvement. If made more practical, quantum engines could have applications in charging quantum batteries or cooling down devices like quantum computers, which are known to make errors when warm. And so obviously this could drive us way into the future with our development of quantum batteries and quantum computers and just expand the world of physics to a level we've never seen.
Wow.
Anyways, Lucas, I believe you have something more recent and fun to tell us about?
Yes, so this isn't per se some physics news, but this is a very recent event, and I feel like we should, explore the physics around it, what we're going to be talking about today.
Yeah, okay, go on.
And although it's not necessarily, expanding the world of physics in terms of quantum or in terms of, astronomy, what I'm going to be talking about is quite a recent event, and we're going to sort of talk about the physics of it. So what I would like to speak about now is darts. So, you guys watch the darts?
Not particularly.
No. So, I really got into it recently, and I started thinking, what is the physics behind it? Because these people, they train tirelessly throughout their entire lives, and they're managing to get these tiny little holes consistently. Right? So obviously there's some sort of technique, but in actuality, what is the physics that goes behind these throws? Right? So, as you know, recently the PDC World Championship was held.
Yeah,
that's what it was called. And a man named Luke Humphreys was the champion. He's now the #1 darts player in the world. And hence, thought it'd be fun to briefly discuss these things. So, darts are designed to have a good distribution of weight, right? Including the position of the centre of mass, in order to experience less wobbling during its projectile motion. Right? They're also designed to be aerodynamic, as you can imagine, and stable, which is done with streamlined design and the inclusion of those flight fins. That's what they're used for actually at the end of the dart. When the dart's thrown, they use a spinning motion, right, to improve and to maintain stability and also to help the player's muscle memory. Spinning helps with that, and develop fine motor skills. These are actually, in particular, developed through practice, right? I mean, you're not really going to get it any other way than just keep throwing these darts, right? And this ensures a repeatable and accurate release. Now, the conservation of angular momentum is also important, right, during the release of the dart. And as the player adds the spin, the angular momentum remains constant unless acted upon by an external tool. But for this case, it's rather constant. So these are the sort of ideas that go behind throwing a dart. I just thought it was interesting. There's so much that you don't think about, right? Even to the shape, to the technique of the player. But again, a lot of it comes down to practice. This sort of muscle memory that they build in order to hit those triple 20s. But, just watching it was fascinating. And here we go.
And you're sure they're not just throwing them aimlessly and hoping?
Well, I mean, I've tried, Rohan, and it has not been as successful as them.
Fair enough.
You think you're going to give darts a go?
Well, where there's angular momentum.
Yeah, of course. So that rounds off all the stories we have for you for Newscast 2024.
Thank you for watching.
We hope you enjoyed.